Welcome back to Think Thrice Problem Solving. Today we'll be continuing our American Mathematics Competition series. So the problem we're going to be looking at is if we measure the distance with the one norm. So what the one norm is it's the sum of the absolute value between the x-coordinates and the y-coordinates of 2 points. Our question is how many points with integer coordinates are a distance of 20 units or less from the origin? So if you'd like to give this a shot, go ahead and pause the video and try to work it out on your own. Otherwise, let's go ahead and jump into the solution. So as we look at this problem, so we notice that we're taking the distance as the sum of delta x plus delta y. So it's basically the sum of the number of steps in the x direction plus the number of steps in the y direction. So if I go 2 units to the right and 2 units up, then my distance is going to be 4 because I've taken 4 total steps. Okay, so I want to be 20 units or less from the origin. So let's go ahead and look down at our plot. What is that going to look like? So if we're 20 units or less from the origin, so one way we could do it is we could just jump all the way over to 20. And if I do this, I'm going to end up taking 20 steps to the left or 20 steps to the right. And notice that what we said is that it has to be no more than 20. So 20 or less. So that means that I could also stop at 15 or 3 or anywhere in between. Okay? So any of those would also be valid solutions to my problem. So just on this number line, so without taking any steps in the y direction, there are going to be 2 times 20 plus 1, because I also have to include the origin itself. So there's 2 times 20 plus 1 possible places I could land. Okay? If we were instead to go out to 19 or negative 19 and then take 1 step up or 1 step down, we would also be fine. And just like before, I could also go anywhere in between to any of those integer coordinates, and that would also be a valid point. So I could do the same thing on the bottom if I go 1 step down. So as long as I'm just taking 1 step up or 1 step down, I can go anywhere within that window. So what I've just noted is it's going to be plus 2 times, and then I've done at each, so if I just look above, it's going to be 2 times 19 plus 1. And then I could continue if instead I go 18 spaces out and go 2 steps up. That's also a valid solution, and then I could go anywhere in between, and I could do the same thing below. So there's also going to be 2 possibilities here. It's going to be plus 2 times 18 plus 1. And once again, there's 1 above and 1 below the x-axis. And it turns out I can keep doing this all the way up until I'm just at the single point here. So at the single point, I'm going to end up with just 2 times 0, because I'm taking 0 steps away from the x-axis, plus 1. Okay, so let's go ahead and write this a little bit of a different way so that it's easier for us to calculate. So my sum, so my total steps, it's going to be 2 times 20 plus 1, so 41, plus, I'm going to take all of these guys and write them in a summation. So I have 2 times the sum from n equals 0 to 19 of 2 times n plus 1. Okay? And I'm going to kind of write that as 2n plus 1 so we can see all of that's inside the summation. So let's go ahead and look at just our summation now. So let's take a step back and look at the summation to figure out what this guy is. So if I look at the sum from n equals 0 to 19 of 2n plus 1, first I'm going to look at this guy. So I'm just going to be adding plus 1, and I'm doing that 20 times. Okay, so this is going to equal, pull that guy out, 20 plus the sum from n equals 0 to 19 of 2n. I can take that 2 and move it out, because the 2 is multiplied by everything in this set. So this is going to be equal to 20 plus 2 times the sum from n equals 0 to 19 of n. And then looking at the sum from 0 to 19 of n, so that's going to be 1 plus 2 plus 3 plus all the way up to 17 plus 18 plus 19. So what I can do is I can add 1 plus 19, and that's the same as adding 2 plus 18, which is the same as adding 3 plus 17, and it'll be so on and so forth as I go in. So what I'm doing is I'm adding 19 plus 1, and I'm adding that together. So 19 plus 1, and I'm going to multiply that by 1/2 of the no total combination. So I'm going to be doing 19 plus 1, and I'm going to be doing that 19 over 2 times. And you might notice there's an odd number, so at the reason we're doing 19 over 2, so that gives us an odd number because there's the middle term, and when I multiply it through, that's just going to be adding 10. Okay, so we now look at this. We're going to have 20 plus 2 times 20 times 19 over 2. So these two guys cancel, and I'm going to be left with 20 times 19 plus 20, which is just 20 times 20, which will give me 400. So if I go back to my equation above, pull this guy down, so my total number of steps and spaces possible is going to be 41 plus 2 times 400, which will give me 841. So there are 841 integer coordinate spots on our coordinate plane where we would be able to step, and we would have a distance of 20 or less from the origin. So I hope you enjoyed working through that problem with me. If you did, please like and subscribe. If you have your own problem that you'd like me to do, please feel free to email it and submit. Otherwise, as you're working through problems on your own, think once, think twice, and if you really get stuck, think thrice.